In the last section of Chapter 3, we're going to talk about proving angles congruent. In this video, we're really just going to learn two new-ish theorems and go through one proof. So some more properties that we're going to add to our list of things that we could use as reasons in a two-column proof is the vertical angle theorem. And we've already kind of talked about this a little bit already, but vertical angles are all congruent. So angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Remember, vertical angles are the ones that are opposite of each other that share a vertex. Also, just to make sure we understand this symbol, congruent means the same. We use that a lot in geometry and in proofs. And the symbol for congruent is literally just an equal sign with a little tilde on top. So I just kind of wanted to go through the proof of the vertical angle theorem. This is going to be a little bit of a more complicated proof than we'll see in class as we first start this unit, but I thought it'd be helpful to kind of go through it one time. So we're given that angle 1 and angle 3 are vertical angles. We want to prove that angle 1 is congruent to angle 3. So we're proving the vertical angle theorem. We're acting like we don't know that these are equal angles yet. So we got our statements and reasons, and let's go through trying to prove that 1 is equal to 3. Angle 1 and angle 3 are vertical angles. That's our given statement. That's always what we want to start with. And here, just looking at that diagram, angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. And the reason for that is that angles that form a linear pair that form a straight line are always going to be supplementary. And what I know about supplementary angles is that they're two angles that add up to 180. So I can say that angle 1 plus angle 2 equals 180, and angle 3 plus angle 2 equals 180. And that's just by the definition of supplementary angles. Notice here that both of those equations equal 180, so if angle 1 and 2 add up to 180, and 180 equals angle 3 plus angle 2, I can kind of get rid of that 180 as a middleman and just say that angle 1 plus angle 2 equals angle 3 plus angle 2. And that would be by the transitive property. From here, I see that I have an angle 2 on both sides. I could subtract that out of my equation to simplify it. So I'm left with angle 1 equals angle 3 by the subtraction property. Now that might look like our proof technically is done there, but just to be proper here with our proof, I'm going to finally say that angle 1 is congruent to angle 3, and my reasoning for that is that angles with the same measure are congruent. Now there's one more property that I want to talk about. It might seem pretty obvious and straightforward, but it's that all right angles are congruent, and we'll use that a decent amount here in some upcoming chapters. So I'm going to look at an if-then statement here. If angle 1 and angle 2 are right angles, then I can assume that angle 1 is congruent to angle 2. And that's because if you're a right angle, you're 90 degrees. And as we know, angles with the same measure are congruent. So if angle 1 is 90 and angle 2 is 90, they have the same measure, they're congruent angles.